We're going to talk about the domain and range, generally of functions. The domain, you probably heard this one before, it's your set of all possible x values, and the range can be the set of all possible y values. So again, we're going to look at the three types of usual function representations to discuss how we can answer these questions. We'll start with the simplest one, is when we just have that list of points. So let's say we have our function f is going to be defined to be this weird list of points, -5 and 2. I'm just making this up as I go. Let's say 0 and 7, 3 and 1, 4 and 2, and let's go with 9 and 0. Okay. So the x values for our domain, again, they're just always the first coordinate in these lists. So these are our x's. We really just need to list them to get our domain. So again, you can use those squiggly brackets. And if I list them, I actually already wrote them in increasing order, but you don't have to. But I have a -5, 0, 3, 4, and 9. So it's just my list of x's. And my range is just the y values. Maybe I'll do those in a different color. I can see here we've got 2, 7, 1, 2, and 0. So 2, 7, 1, 2, and 0. That is a perfectly good answer for my range. It's a little bit of overkill because I did write 2 twice. It's the exact same thing as just writing, let's say, 2, 7, 1, and 0. Yeah, that's a perfectly good representation. There's no need for it to be in order, but if you're really fussy, maybe I can write it in increasing order, 0, 1, 2, 7. So any of those answers should be good for your range. They're all the same set. Yeah. All right, graphically can be a little bit tricky. So we're going to do one of those examples. Sometimes it involves a little bit of set manipulation. So let's go with, try to make something up that has got at least a little bit going on here. And I will need to be somewhat clear because we do need these numbers. One big difference between usually drawing things as graphs and those collections of points is that in a graph, we usually have curves and lines, and those represent all the points in between. So you wouldn't really want to just write like a list. It doesn't make sense. So I'll show you what I mean here. Let's say I write that point there, and I'm going to go and maybe draw an open dot there. And let's do an open dot here to a closed dot there. Okay, so domain and range are again just talking about your x's and y's. I think I'm actually going to add a little bit more to that because I want to really emphasize something that I'll see a lot of times with these answers. And maybe I'm going to close this too. Okay, so maybe just to get this one started, I'm going to break it into, let's say, like chunk A and chunk B. So for chunk A, what we've actually got, if I look at the domain, it's the x's. The domain are going to be essentially all of these x values from what looks like, according to my graph, again, I'm not writing the numbers because I'm lazy, but I'll write them out now. That's going to be -4 to -1. Now, I want to be really careful with this. It's not this set, -4, -3, -2, -1, and that would actually just be it. Because this set is missing all those decimals in between, right? I've got a point right there at like -2.5, and then I've got a point here at -2.4. It's everything in between. So we actually need an interval for that. So it's actually going to go -4 to -1. And you'll notice I use these square brackets here. The square brackets, remember what they mean is that we are including the endpoints. -4 and -1. And that's indicated on the graph here because of the fact that I colored in those two circles. And then my range, so that's going to be actually all the y values that are hit. So that's going from -2 all the way up to +1. And again, it gets everything in between because that's a curve. That curve hits all of those values in between. Everything on that curve represents a point that's actually there. So it's going to be another interval, -2 to +1. Okay, so for chunk B, I'll do the same thing. I'm going to write my domain. So in this one, it's those x values. So it's going to come from, you can see +1. And then it only goes to 2, but notice that that is an open dot here. So what that means is that it gets really close to 2, but doesn't actually include 2. So it's everything up to 2. So as far as our bracket, the way that we would represent that is 1 and then 2, and then that's where we get that round bracket. And so what that means is that it's including, let's say like 1.9, 1.99, 1.999, etc. So all things that are really, really close to 2 on the left-hand side, but smaller than 2, but not 2 itself. And so that's what we are getting for our domain there. And then our range, same idea. The range, you can see that open dot is the lowest point at 0, and it's open, so it doesn't include the 0. I'm going to use that round bracket, and it's going to go up to 2. And that's a colored in circle, so I'm going to use a square bracket to indicate that it is including that 2. And so to get the actual domain and range of my function, it's the union, it's the combination of these two piles. So my domain is actually going to be of the overall function. It's going to be the union of the two sets. Yeah. So for that one, there's actually no overlap in those two sets, right? If you look at it on the graph, I mean, the fact that it's a function, there shouldn't be multiple x's in these two chunks. But yeah, so the first one is coming from over here on the left side, and the second one is over on the right side of the graph. So there's no overlap at all. That's pretty much as simplified as I'm going to get. And my range. So again, I'm just going to union these two sets, -2, 1 with 0, 2. Now there actually is some overlap here. If I were to draw these out, if I'm looking at what's going on over here, I'm just going to draw this on the left. So what I can see is I've got this 0 to 2 chunk right there. And then I've also got -2 to 1. Now, if I do the union, what I'll end up getting is, you can see there's all this overlap, right, taking place in that region there. But it's just going to kind of collapse on top of itself. So if I just were to sort of pancake all of this down onto that y-axis, I basically can see that I have everything from -2 to +2. So if I do the union of those two regions, I'll get -2 to +2, including the endpoints. This is technically the answer, but it's not a very nice way of writing that answer. So I'll do -2 to 2 like that. And so that should give me the range. Fortunately, we aren't going to do a lot of looking at graphs like this and finding the range. This is unnecessarily difficult, particularly because we tend to be more interested in the domain than the range. It's often usually actually a much easier question to answer. And I'll give you a last example to illustrate that. And obviously the last one's going to be an algebraic expression. All right, yeah, I'm gonna make something a little ugly here. And maybe just for the sake of a review, I'm gonna get some factoring in here. What should I do? Let's try this. That should do. Yeah. Okay. When we're asked about domain and range when you have an algebraic expression, one thing you could do is actually graph it. There's lots of software that you could use to do this. But let's just say that you don't have access to that. There's a really easy way to find the domain. What you can do for the domain is look for things that cannot be plugged in. So the domain in this case is going to be the x's that can be plugged in. And the way we're going to find them is by sort of canceling out the things that can't be plugged in. So at least with some of the algebraic expressions we're familiar with, we do know that there's certain things we can't plug into certain operations. For example, if we're in this universe of real numbers, we can't plug negatives into a square root. This is something that's probably even a little more familiar to you. Here we've got division, and we know that we can't divide by 0. So we're looking for our restrictions. And so what we should be asking is, what x's are going to make us divide by 0? Well, it's when the bottom is 0. So that's what we're going to be looking for here. So let's figure out when that happens. And so my little factoring review here, remember what we're looking for is two numbers that add to the middle and multiply to the last number. And hopefully you can see that the numbers should be -5 and 2. So usually my trick is that I look at the fact that the multiplier is a negative, which tells me that the two numbers have to have a different sign of each other, right? If they're both positive or both negative, that's a positive. So they have the opposite sign, which means that one is going to get subtracted from the other. and the difference of 5 and 2 is 3, so that works. And then it's just a matter of which one's positive and which one's negative. But that's going to tell us how this thing factors. Right, that's where those two numbers go, -5 and +2 equals 0. And then we should be able to get these two solutions here. Yeah. It's 5 and -2. So basically, yeah, our only problems for this are going to be when x is 5 and x is 2. So we can say for our domain, we could write this two ways. We could say that x can't be -2 or 5. If you like your intervals, and I think some of the homework's going to make you write these as intervals, we would basically write -infinity to -2, so everything up to but not including -2, and then -2 to 5, and then we have to skip over 5 as well, so 5 to infinity. So it's like your whole real number line, -infinity to infinity, and then we have to hop over -2 and then hop over 5, and that's what this is doing here in the interval notation. So that's our domain. And then, well, I also asked for range. Well, I didn't ask anything, but you probably are wondering about range. Basically, that's a much harder question. If you want to find the range, you probably would have to actually graph this. It's not quite so simple as like what y values can you not plug in. You'd have to actually rearrange for x and try to solve it that way. So I'm just going to leave it as that's a harder problem. So if I were to ask you for the range, I probably would expect you to actually be able to graph this. And we'll talk about graphing things like this expression here in the second chapter, but we're not there yet, so I can't really ask you that yet. So all we'll stick with for that one is the domain for now. So that should wrap up the discussion of domain and range. Yeah.